Hello everyone, welcome back. Today we are going to dive into the topic known as composite functions. This is a very straightforward and easy topic, so let's break it down. First, we're going to talk about what exactly are composite functions. And secondly, we are going to solve the three kinds of questions that arise in SPM. Once you can solve these three questions, you can solve any composite function question in SPM. So firstly, what is a composite function? You can think of composite function as a long line of functions which we sort of combine in order to make it easier to run the whole function. So what do I mean? Take this Maggi Mee packet for an example. This Maggi Mee packet will be our object, so it is x. And the first thing you want to do, the first function you want to run it through is to add water. And so we can call our function f. So once you f the x, pardon my language, once you f the x, it becomes fx. Right? So this is your image. But you can't stop there because no one wants just soggy, wet noodles. You want to do something more. You want to do the next step, which is to boil the water and add seasoning. And we'll call this function g. But then how do we express the final product? Because it's not x anymore. The new object is fx now. Right? We're putting fx into the function g. So it's very simple. All you have to do is treat the fx as an x. So you just write g and put fx next to it. Alright? And this is very important because it helps us simplify the entire process. So imagine if you're telling your mom that you want to eat noodles. You don't go and tell her, Mom, can you please give me the noodles, add water, boil it and season it, add eggs and tofu and fish balls and whatever. No, you don't tell her that. You just say, Mom, I want you to cook Maggi Mee for me. Right? So you will have this GFX, which sort of summarizes the entirety of the line of functions for you. And that's the amazing power of composite functions. Alright, now let's move on to solving the three kinds of questions that arises in SPM, because let's be real, that's all we kind of really care about. Now, the first kind of question is this. It's where they give you fx, they give you gx, and they expect you to find the composite function. This is the easiest kind of question. So the first step, as you can see from the right, is to write fgx. Very simple, write fgx. And you equal, now what you're going to do next is you're going to sub gx, i.e. this thing, into the equation. So instead of writing instead of writing gx, you're going to write x plus 3. Right? Because you're going to input the value from here into here. And then next, you're going to treat the gx as the new x. Alright? So instead of this x here being just an x, it's going to be x plus 3. So similarly, in here, x is going to be x plus 3. So let's write that out. Instead of 2x, it's going to be 2x plus 3 minus 1. Right? Do you see the similarity? 2x minus 1, 2x plus 3 minus 1. The x has essentially evolved into x plus 3. And now we open the bracket, we'll get this. And that's our answer. Easy peasy. Now, let's move on to the second kind of question, which is where they give you the composite function, but then they also give you the outer function, i.e. fx in this case. And you have to find the inner function, in this case, gx. The first thing to do is to write out fgx. And we know this equals to 8x minus 2. And on our second line, we are going to sub fx into this equation. And we're going to treat gx as sort of an x, right? So you're going to see what's going to happen. Fx is 4x plus 2. But instead of 4x plus 2, it's going to be 4gx plus 2. Because we're treating the gx as the object, i.e. gx is replaced into x. and this would be equal to 8x minus 2 still. And now all that's left is to solve for gx. So you just want to move everything to the other side. And that's what we're going to do. When I move the 2 to the other side, it's going to be minus 2 minus 2. So 4gx equals 8x minus 4. Gx, everything divided by 4, it would be this. And that's how you do the second question. Fairly simple as well. Now the last question, the last type of question is the tricky one. This is where you get a composite function, and they give you the inside function, and they want you to find the one on the outside. That's the one that's hard, right? So the first step is to, again, write out f g x. And here we know that f g x equals to 2x plus 5. And the second step, as part of the first step, what you want to do is sort of put the x plus 3 inside the gx. So you're going to get something like this. F x plus 3 equals 2x plus 5. Right? And we have to take a little stop here. Let's just put a pause here. We're going to go on to the second step, which is to let y equals to gx. So I'm going to let y equals to, and gx is x plus 3. So x plus 3. And the third step is I'm going to find x. So all I have to do is sort of move the 3 over to this side. And I get x equals y minus 3. Right, now this is where it gets freaky. This is what you have to do. You have to find fy. So I'm going to write fy will be equal to, and it's going to be very similar to this. Right, you're going to impute this here, but instead of using x, we're going to use what we found x to be in our previous step, which is y minus 3. So instead of 2x, we have 2y minus 3 plus 5. Right? And let me just finish this. Right? So we have this fy equals 2y minus 1. And therefore, we can conclude that fx equals 2x minus 1. Essentially, just replace the y's with x's. And you might be asking, how can we do that? X is clearly different from y. Well, in this case, it's not really different, because x and y are sort of just placeholders, or just a representation of the object that you put into the function. It doesn't really need to be equal to any number. It is sort of just a placeholder we put there to signify the object that is going into the function. So if it's fy or fx, it doesn't matter, as long as your functions also correspond to what the object actually is. So if the object is a y, this must also be y. If the object is x, this must also be an x. And that's all. So once you can solve all these 3 questions, you are set for composite functions and nothing can stop you. Thank you for watching this video, and I'll see you guys again next time.